Hello, welcome to Machine Learning with Python course. So in this video, we are going to get an overview what is machine learning and why we are using Python language for machine learning. So let's get into the detail. So before going in detail what is machine learning, let's get an overview where machine learning stands actually. So AI, machine learning and deep learning are not same. So artificial intelligence is a platform where we implement machine learning or deep learning techniques to get the better solutions or better predictions. So artificial intelligence is a technique which enables machines to mimic human behavior, where machine learning is a subset of AI where we use statistical methods to enable machines to improve with experience. And the deep learning is a subset of machine learning where we use multi-layer neural network systems. So where machine learning fails, deep learning comes into the picture. For example, if you have a tabular data, for example, if you are going for a mall, so if I want to purchase some, if I'm running a mall, if I want to know a particular shop, in a particular shop whether sales are doing better or not, so whether I need to continue that particular shop or not. So where we are going to get an data from the person, from the mall person, how many customers are coming to you and how much purchase is happening. So where we have a particular structured data is there. So how many customers are coming, how many quantity they are taking, and how much price it is. So we have very clear structured data where machine learning plays a very good role over there. But when it comes to the image data or videos or text, so these informations are not in proper structure. So they are unstructured. So where machine learning fails to give the better results. Even we can apply the models, but it's not going to perform better. So in such manner where deep learning comes into the picture, where we are going to work with multi-neural networks. Anyway, when we are going with the deep learning module, so you can get over there. So this particular video or this particular course is we are going to concentrate completely on the machine learning. Okay, what is machine learning? Making a machine learn without explicit programming. So what do you mean by that? So we don't need to code so much to get a better solutions. The reason why it is we are using a Python language. So the Python has extensive libraries where we can use those libraries which are ready-madely available, and we can implement on the data, on the real world data. So in if you look at in a traditional definition, a computer program is said to learn from the experience with some class of task and performance measure. If it performance of tasks in T as measured by P improves with E. Okay, when you read at a time, it looks a bit confusion. So let me make you with a small example. So just try to understand as simple as possible with the real life examples. So if you look at it in our school days, so a teacher is a person who teaches us where we are a learner, right? So how could teacher would come to know whether student is doing well or not? So what she do? She's going to give lessons to us. She's going to share her experience, or she's going to share the knowledge. How she shared the knowledge? With her experience, like whatever the knowledge she had, based on that she's going to share knowledge with us. And if she want to know whether you understood or not, what she will do, she will ask you to do some task. Means she will conduct an exam. Okay, she conducted exam. So how she will come to know whether you understand well or not? She measures the performance, how well you are doing in the examinations. If you are doing well in the examination, yes, you are doing really good. I mean, you understand the concepts. So this is the way. So where we are going to do, we'll take a data set from the past. From the past, we have so much of data. With the help of statistical model, we'll perform a task. So what task has to be performed? For example, for whether cricket match is going to be play or not, based on the humidity conditions or forecast, and so many features will be there. So based on that, we are going to perform a task and we'll measure the performance. We have so many validation techniques, how better the model is performing. Anyway, we are going to see in detail when we are going in much deeper in the machine learning course. Okay. This gives an overview of machine learning, what are the different types of machine learning are. So if you look at it, these are broadly classified into 3 types. One is supervised, unsupervised, and reinforcement learning. So by the name itself, we'll understand supervised in the sense under visual lens, right? So in supervised learning, what happens is when you are taking a data, we'll know what is input and as well as output. So we know X and Y. In unsupervised learning, we know only X. We'll just give the input data. There is no output. And reinforcement is a different kind of machine learning. Anyway, in this course, we are not much dealing with the reinforcement learning. We are working on supervised learning. And unsupervised, we are concentrating only 1 or 2 because most of the techniques have been replaced with the deep learning techniques. For example, the hidden Morgan model. So right now we are not dealing anything with it. So we are completely replaced with the deep neural networks. So in this particular module course, we are much more because 90% of the problems in the real world are the supervised problems. 10% of the unsupervised problems. Anyway, we are going to cover supervised and unsupervised models when we go into the detail. This just want to give an overview what exactly how many different types of machine learning is there. Okay. If you take a model, if I want to perform the machine learning modeling, so what is there inside? Okay, now I got a data. So what should I do with the data in machine learning? So we get a data set from outside person. If not, so we need to create a data as per the requirements. And then there are some pre-processing steps, which is data cleaning and the feature engineering. Data cleaning means if you have a data, there may be a lot of missing values would be there, and there might be a lot of irrelevant informations will be there. So where the data cleaning process is nothing but we are going to fill all the missing values. We are going to clean the data. And feature engineering. Feature engineering instance, we are going to extract what are the important features for us to consider. For example, there is a one, anyway, we are going to work on it as well, Titanic dataset. So if I want to know whether a particular person has been survived or not in a Titanic accident. So in that, if you look at the features, we have ticket number, male, then sex will be there, whether male or female, and age, right? So we have a few parameters and few features will be there. Among that, if I look at it, I need male or female, because if you look in the overall scenario, in Titanic, most of the women have been survived compared to men, right? And the children has been survived compared to the others as well. So they have given importance much to the age and the sex. So these two are the, so there is no need of ticket number. So that is an additional feature which doesn't make much impact on the result, right? So that is how the feature engineering works. So we are going to segregate what are the important features are there which are not relevant to it. So what are important, we'll just consider those features and we'll work on it. So once we're done with the feature engineering, then if I want to perform the model, so I need to split into the 2 datasets which is existing. One is for training and one is for the testing data, means new dataset, right? Because whatever the model I'm performing, that has to perform well on the new coming data, right? So if I have some knowledge, for example, if my teacher is there in a school or some engineering college or wherever, so your lecturer is going to give you some lessons and he will ask you to learn few questions, and he'll give some questions and ask you to learn. And if you give same questions in exam, you'll do very good, you'll get 100 marks, right? But if I give new question, then he will come to know whether you're performing well or not. So what are the questions I have? If I get the same questions, obviously I will do well because I learned those things. So that's not the right way of modeling. So I'll give the training data. Among all the data, some set of data I'll take as a training. Some data I'll keep it as it is. I'm not going to perform any modeling on the testing data. I'll just perform on the training data. And I will check whether my model is performing better or not on the testing on test data. So don't worry. This is just I'm giving a theoretical explanation. So when we go in the modeling, so you'll be getting a very clear picture when you are working with the complete data sets and all. and the learning algorithm. So we have so many different algorithms. Just now we saw in the last slide. In the supervised learning, we have regression, detection tree, random forest, so logistic regression, SVM. So these are the different learning algorithms. These are the models, different models we have. We are going to work on it, and we are going to train the model. We are going to perform the statistical methods to train it, to understand the relation between the features and the output. So once we are done it, so we are going to check with the new data. Score means nothing but the accuracy. So on the new data, how much accuracy is there? So after that, we are going to do the evaluation. Evaluation, we have so many different validation techniques, which is classification matrix and all. So don't worry at this time. So anyway, we are going in detail once when we are working with the evaluation methods. These are different type of neural networks in terms of deep learning. I'll just give an overview because because deep learning is a subset of machine learning as well. But this has a separate module where it is completely very much depth to understand these concepts. So these are different types of neural networks. Neural networks, in sense, basically, it has been taken inspiration from the human brain. So if we know in human brain that a lot of nerves has been connected to one to each other. So we are going to perform the same operations. We are going to connect different nodes to the each node, and we have input layer, hidden layers, and the output layer. So don't worry at this point of time. I'm just giving in just overview to understand this. So based on our how our neural networks works, our neural scheme, our neural system works, we are going to implement the same system over there. If you look at it, these are the different type of problems where we look in the machine learning. So when we are dealing with the problems, basically we have two categories. One is classification and regression. So these are the only two major classifications where all machine learning problems come into the picture. Classification in sense either yes or no, 0 or 1, or categorical type. So you are going to have a definite value whether this is going to be this. For example, email spam, whether the incoming email is spam or not. Image recognition, whether this person belongs to him or not. If you give some image, if you train the model for cat model, if you give cat image, then it will say it is cat. If you give dog, it will say it is not a cat or it's a dog. And then medical is diabetes, whether he has diabetes or not. Breast cancer, whether he has cancer or not. So this is all binary, like yes or no, or categorical type. So those are the classifications. So regression is a kind of problem where we are going to have a continuous value. It values from 0 to some, like real number. It's not like 0, 1. It will be 0 to 1 or something. Payment credits, how much payment, time subscriptions, grade shopping. So don't worry at this point of time. I'm just giving an overview exposure. So when we are dealing with, we are going to work with the classification and regression problems for each and every model in the course of meantime. If you look at the real world applications in machine learning, you can see the traffic alerts, social media. Nowadays, what we are looking in, how much posts, what kind of posts are happening over there, and what among the social media. If you look at a Facebook, you can see the advertisement recommendations that would be coming up there, so on, so etc. And the product recommendations. If you look at the Flipkart, we will get the recommendations. So based on your previous search data, it's going to recommend the product for you. Then virtual people assistants like Google, Alexa, and all. This is an unsupervised learning actually. Self-driving cars, which is a reinforcement learning, which is also a machine learning. Google translations, fraud detection, online video streaming. So these are the few real-world applications in the machine learning. Thank you.